All right, so welcome to DataLab5. Today we are getting very close to being able to run a multi-level model, which will allow us to do a bit more formal testing about whether increases in happiness are associated with increases in curiosity. So we looked at those associations a little bit with intra-individual correlations and intra-individual regressions, but you really want to be moving to the multi-level model to account for some of the data issues we talked about in DataLab4. So before we can do that, though, we need to split our predictor variables into within-person and between-person components. And so we'll go into detail about why we're going to do that in a minute. So first, we want to let OR know where our data are. And again, we're just going to be working with the daily diary data. And I'm going to take the average of my curiosity variable, but I'm actually not going to look at the curiosity variable that much at all because you only have to split the predictor variables. When you plug these variables into the multi-level model will take care of splitting the outcome variable, so you don't have to worry about it. Okay, so just the bigger picture here is that intensive repeated measures data simultaneously contain between-person and within-person information. So if we look at a person's daily diary data, this is a person's data for curiosity in blue and happiness in red over time. And it simultaneously contains information about this person's average happiness and average curiosity. And that's shown by these dashed lines, as well as information about how these two variables are changing over time. And we can kind of see that more clearly when we look at a second person. So the means are different, not that much actually, but they are. And if we looked at a different person, we could find even more marked differences in the average levels of these variables, as well as differences in how they're fluctuating across time. So our goal is to use a multi-level model to answer two questions. The first is that when happiness is higher than usual, is curiosity also higher than usual? So we're going after a within-person association between happiness and curiosity. And we can even be a little bit more specific and talk about the timescale at which we're able to talk about things. Because we have a daily diary data set where we're doing things one day at a time, we can say on days when happiness is higher than usual, is curiosity also higher than usual? And when I'm talking about higher than usual, I'm talking about higher than usual for that person's typical level of happiness and curiosity. But we can also ask the between-person question, which would be more along the lines of, do people with higher than average usual, I should put average there, higher than average usual levels of happiness, so when we take into account their average level of happiness across the 21 days, also tend to have higher than average usual levels of curiosity. So, and when I'm talking about higher than average, now I'm talking about higher than the average individual in your sample. So one part of the model is looking at within-person associations. How do I compare to myself across time? The other is talking about between-person associations. How do I compare to other people? All right, so to distinguish between these two things, we need to create a within-person variable and a between-person variable for the predictor. And you can read more about the need to disentangle within-person and between-person components in this really nice paper here. Okay, so let's do this. The first thing we have to do is to get the ground mean of our predictor variable, in this case, happiness. And the ground mean is just the average of each participant's mean. The reason we do this is that it becomes very useful for interpreting the variables. As we'll see in a minute, it will make it so that 0 becomes a meaningful value. It will be the average happiness value for the average participant. Values above and below 0 will then be levels of happiness that are higher or lower than the mean. So we've used this function before. We're just taking the average of each person's happiness. And we can describe that. And so the average level of happiness in the data set is 69.89, and we can set the grand mean just by creating a new variable called happy grand mean at 69.89, which was the mean up here. Boom. And now we're going to subtract this grand mean from the raw scores. And actually, let me just show you what this grand mean looks like so it starts to make sense. This is going to be, every row in our data set is going to have the same value now, okay? So it's like the average happiness for our sample. And when we do this, when we take this grand mean from the raw scores of happiness, I'm just calling it happy C because it's centered, C for centered somehow. Our happiness is now no longer on this like 1 to 100 scale. If it's below, if it's at 0, it's the same as the grand mean. It would be 69.89. If it's a negative value, then it's a value that's below the grand mean. If it's greater than 0, it's a value above the grand mean. We're still not at our between person variable yet. What we next want to do is to using very similar code that we had up above, create a between persons mean from this grand mean centered variable. I'm calling it happy BW for between. Okay. By the way, this never makes sense to me until I actually have to plot it and look at the variables. So to kind of help just get what is happening here, have a read of this, but also just run the code on your data and look at it and kind of think through what it's actually doing. That's what I find helpful. So when we do this, now we have a between person happiness variable. So it's one value for each row in each participant's data set. So for one person's 21 days, it's the same value. When we go to another person, it's a different value. But now you can interpret it as if it's below 0, then that person has an average level of happiness. So their average of their happiness across the 21 days is a little lower than what the average person's average happiness is. This is still probably super confusing. If it's a positive number, then it means it's higher than the average person's average happiness. And just to kind of reinforce this idea, or to make it a little bit more clearer about what it's actually doing, we can take some descriptives of this between person happiness variable, and you'll see that the mean is 0. And then when we plot it, so each person's value, each person is a line here, and they have the same value across all of their 21 days. Again, it's not capturing fluctuations. It's capturing information about their kind of average level, their mean level of happiness throughout the 21 days. But now, rather than going from 1 to 100 like it was on our original scale, the prototypical person, so the average person, is at 0. And if you're above 0, you are exhibiting greater happiness than your typical person. So you're a person who tends to experience more happiness than the average person. If you're below 0, you experience less happiness on average than the average person. And this is across your 21 days. It's not taking any time variation into account. Okay. And again, we can look at a histogram, and the average person's at 0. Some people are above, some people are below. Okay. To get our within person variable out of here, that will allow us to ask questions about, when my happiness is higher than it usually is relative to how I usually am, what is my curiosity doing? We create a new variable that's called happy WN, happy within, and we take this centered happiness variable from above, and we subtract this between person mean. And what that will look like is this. Now it's relative to myself. So if it's 0, it would be a typical day of happiness for me. If it's below 0, it's a level of happiness that's lower than my usual level of happiness. If it's above 0, it's a day of happiness that's higher than it usually is for me. And again, we can make this clearer by just doing some descriptives on it. It's centered at 0. And when we look at an individual's happy within variable, we're no longer on the 1 to 100 happiness scale. We're on a scale where 0 is a meaningful point now. 0 is my average level of happiness, and this will be the same case for everyone in the sample now. 0 means it's a day of average happiness for me. It's my typical level of happiness, and values above 0 are days of higher than usual happiness for me. So they're above this prototypical average day line for me. And days with values of happiness below 0 are days of lower than usual happiness for me. And so just to convince you that this is the same for everyone in the sample, we can take a different person who had a different average level of happiness in the study than participant 105. And the 0 is now at their average. So it's a day of average happiness for that individual. It's a person-specific mean of their happiness. And values above it are days of higher than usual happiness for them. Days below 0 are days of lower than usual happiness for them. Okay. This is probably confusing. Work through the data, work through the code, put in the variables that you care about, and just kind of look at what the code is doing. Look at the data that is outputted at each step and make some plots, and it will start to become clear that now you have two types of variables. You have one that can help you ask questions about between person differences, and another variable that will help you answer questions about within person differences. Okay, so we're pretty much all set to run the multi-level model, but we're going to do that in the next data lab. But before going any further, I did want to do one additional thing, which is about lagging the data. So if we move forward with our happiness and curiosity variables right now as they are, we'll be able to answer questions that say, on days when my happiness is higher than usual, my curiosity is higher than usual. But sometimes you might want to look at lagged associations. You want to say, if my happiness was higher than usual yesterday, my curiosity today is higher than usual. Maybe you have a theory that says the effect of happiness takes time to kick in. So your happiness is increased yesterday, you do something, you just feel different, but it doesn't impact your curiosity until the next day. So some examples where this is very common are things like my alcohol use yesterday affecting my negative mood today, my hangover today, my sleep today, because right, you might feel pretty good on the day that the day that you're drinking alcohol, but the day after, especially if you drank a lot, you would have kind of hangover symptoms potentially, and so that would be a case where you would want to lag the variable. So how do we do this? There's a package out there called Data Combine. So again, you might have to install this. And we're going to lag, they call it slide, our happy within variable. And we're going to do this by ID. By putting ID in here, it stops the data set from just like shifting up and then one participant's data shifting into another participant's data. And we're going to slide by -1. So we're going to look at 1 day previous. You can change this. It could be -2. It could be +1, where you'd be going in the opposite direction. You can play around with this and just look at your data. I always find lagging confusing. So again, what I typically do is I run the line of code, and then I go to my data set to see if it's doing what I think it's doing. So now I have my happy within variable, which is my current day within person-centered happiness. But now I have a new variable that is happy within -1. So it will add whatever number you add here to the variable so you can distinguish it, which is nice. And so now if I'm predicting curiosity today, my curiosity variable today, I have the option of now predicting it with yesterday's happiness. Because if you see the happiness for this day is yesterday's happiness, right? Do you see that? Cool. So it's pretty simple. It can take a little while to wrap your head around what the appropriate lag will be, depending on the type of data you have. But my suggestion is to always run the code, look at your data, make sure it's doing what you think it's doing. This happy within -1 isn't the nicest kind of naming convention. So I like to rename this to say happy within lag, for example. All right, so that's all I wanted to go over in today's data lab. A lot of this manual splitting of within and between predictors doesn't have to be done in the arduous manual way that I did it up above. I just walked through it like that because it helps me make sense of what's happening to the data, and I can look at it at each step. But there is a package that you might find useful called EMA tools that I'm putting here. My postdoc, Amanda McGowan, has used it in the past and she really likes it. So I would suggest running through it manually first so you have an understanding of what's happening underneath the surface. But then if you want to make your life easier and have a function that just does it in one fell sweep, feel free to check this out. Okay, cool. All right, have a good rest of your week.